Inheritance is awesome until it breaks your code. Today I'll show you a safer, cleaner way: composition. By the end of the video, you will know the difference between inheritance and composition, learn when to use composition, build classes that work together instead of forcing hierarchies, avoid deep inheritance problems, write maintainable Python object-oriented programming code. Want to write clean professional object-oriented programs? Hit like and subscribe, and comment compose if you are following along. So first let's take inheritance recap. Child class inherits parent behavior. Pros are easy code reuse, clear structure, and cons are can get rigid and fragile, and risk fragile base class problem. So you can think of composition as a has a relationship. Unlike us, we all are single. Okay, so for that, let's create a program which will have multiple classes. Class engine, def start, self, print, engine started. And then class car, def init, self, comma, engine. Self dot engine equals to engine, and the other function will be start underscore car, self dot engine dot start, print car is ready. So now how we will call this will look like this. First we will create an object of engine class, then we will create an object of car class with engine in it. Okay, the C was capital. So we just created a relationship here between engine and car. C underscore start underscore car. And now if you run it, okay, I think I made a typo somewhere. Car object has no attribute. Okay, yeah, I mistyped R here. And now if you run it, it will print both of these lines. Engine started and car is read. Why? Because car got a relationship with the engine class. So now comes when to use composition. When you want flexibility, when behaviors can change independently, when inheritance hierarchy is deep or unnatural. Let's look at a hybrid example. First, I'm gonna comment this out and then we'll create multiple classes. First one will be vehicle and function will be move. Print vehicle is moving or vehicle moving. Okay, so there won't be much like very much changes, so I'm just gonna copy them. Okay, so second one we'll take engine and it will say engine started. We can copy this from verb, but let's just type it for now. Then comes class car and it will have def underscore underscore init self comma engine colon self dot engine equals to engine. Then def underscore car self dot engine dot start self dot move. Okay, so now how we will call this. Reuse what makes sense, compose what changes. Okay, so there was an error in our program. First one is we forgot to alter this method and function here. And the another is, and now we will inherit vehicle. Now car will inherit vehicle, and then we can just use the above code to call it, because all the classes are almost same here. So now if you run it, it will still say engine started and vehicle moving. Reuse what makes sense, compose what changes. Why this matters? Why composition matters? Makes code scalable, avoids fragile classes, keeps system clean and maintainable. Now let's talk about some common beginner mistake. First one is overusing inheritance. Second is ignoring composition when it fits. Third is deep rigid class chains. Composition means control, inheritance means hierarchy. Use both wisely. This is how pros structure Python apps. Thank you guys for watching.